Hello. In this session, I will try to explain how reentrancy attacks work. On the internet, I saw a lot of blogs or videos about that, but I think there is some point that we have to discuss together. So I decided to record this video. Basically, a reentrancy attack happens when a function is externally invoked during its execution, allowing it to be run multiple times in a single transaction. What does it mean? Let's first of all check the victim contract together, understand it, and then let's check the attack pattern together. Okay, I write simple contract about that. That's called contract victim. Okay, there is two function exist on that. One is deposit and the other one is withdraw. So this contract doing that basically, we are depositing our Ethereum and then we are withdrawing it back. But there is a vulnerability exist called Reentrancy. Why does it exist? Let me explain it to you. Because it's sending our money back first, and then it says this customer's balance is zero. But what if I can call this function and it sends our money back, and then I call it again? Let me draw that. On here, I call it back, and it's run this way. If its balances, the victim's balance is not zero, then it's again sending our money back. And then I'm calling this again, and it sends money again until it has zero balance. But if you think default functions, you can ask, actually you should ask some question in that point. And that is, how can I cut the function if there is no break or something like that? There is a function called fallback or receive functions on Solidity. That functions basically doing that. I think they write this for developers to have them. This function basically doing that. If you got any Ethereum to your contract, the contract skips the other function and firstly runs that. So for example, developer wanna say, if you got any Ethereum, write this to output. So firstly it's run that and then go back. But if we write something like while address target contract balance is greater than 10, it's looping that, and even we got an Ethereum, we are still here to steal the money. It's work basically like that. So I said that, if you remember, I will call it back. So I am calling it back with that functions. In Solidity, there is a feature that or function type that works this way. So if you got that Ethereum, we call, not we actually, the program calls receive function, and again I'm calling the withdraw function. Then we are again here and it's sending again. And if we got again Ethereum, it calls receive function and we are here again until the victim's contract balance is zero. Then what happened? So we deposit 10 Ethereum, for example, with here, and let's say victim contract has 100 Ethereum. But we deposit 10 Ethereum. Then when we call withdraw, it will send our money back and it will say this customer's balance is zero. But if I call it back when it's here, that breakpoint, it will comes here again and sending again 10 Ethereum, because we deposit 10 Ethereum until the victim's contract has 0 Ethereum. Let's try that in Remixide. If you didn't hear that, Remixide helps to demo your solid codes. So I copy our functions here and compile it. Here is our victim contract, and there is our attack contract. I import that. In the real scenario, you have to import from the address on blockchain. That's a little bit advanced subject, I think. So let me deploy it again. First, Control S and deploy victim contract, and then close this too. Okay, then attack, Control S, and come here. It requires target contract address and also attack amount to deploy money. Let's copy this address and paste it to here. Also here we have to give as way, not ether. So I calculated 10 ether is equals to that. Okay. So first of all, let's say this is a customer. This random customer has 100 Ethereum, and he's going to deposit 10 Ethereum, and victim has 10 Ethereum. And also this is another customer, and he's wanna give 10 Ethereum. Let's deposit. Okay. So this is our contract. We have balance 0, but in order to deposit money, we have to have balance. So I will send from there to test it. 10 Ethereum. AB is my function to get that. So we have on 10 Ethereum, and victim has 20 Ethereum. So let's try to deposit, and we send it to here. You see, 13 Ethereum is here, and we have 0 Ethereum. Let's get 5 Ethereum more, and we have 5. If I run our attack function, let's see what happens. So we have 35 Ethereum, but we only deposit 10 Ethereum to here. So we stole other customers' deposit. So that means is we stole all the money from victim. That can be a bank or something like that in blockchain. So how does it work? I called initiate reentry attack. It's called withdraw function. So it tried to get 10 Ethereum, but when we got Ethereum on that point, let me show you. On that point, I called the receive function. I called this receive function here, and it's again called the target contract withdraw function, and came to here. Until the victim's balance is 0, we got all the money and we stole all of them. We have 35 Ethereum right now. So that's it. The main point is receive function. You need to learn how does it work. It's basically working if you got any Ethereum on your contract, it runs that and stopping that. So even you are on this here, this function still running, it calls to receive first. And the other point is why this vulnerability occur. The main reason is these sentences should be here, because if you put that to here, first program will set the 0 to customer's balance and then send his money back. So even you call that again and again, you have 0, you can't call this one first. So you can't do this attack. But the important part is there is some conditions we need to check. in these functions, but for the POC, I didn't write them, of course, and this is so basic program, but it's enough to understand this attack pattern. That's all, I think. I record that video because the sources doesn't give enough info about how receive works and how this attack works with you. Thank you for listening. See you.